Testing my microphone. Alright, everything sounds great. Hey everyone, welcome to the stream. For me right now it's around 1 a.m. on the 15th of January 2022, and I'm gonna start this stream by reminding everyone to hydrate, as I'm about to do right now. Nice. Let's get started. So, the goal of this stream, if everything goes well, is going to be making a tool to delete half of the files in a directory in a random fashion, as Thanos did to half of the life in universe. Hoping that this is not spoilers for anyone at this point. So, first of all, to see how it's gonna work, let's say there is, where can I go? My music directory. If I pick all the files here, there are the files, and if I see how many lines, which should correspond to how many files I have, that's about 195. So let's see, this tool, once it's done, should leave me with 97 or 98 files once I execute it. Of course, I'll never do it in my music folder because, well, these things are difficult to acquire over time, so you know, they're near and dear to my heart. Let's just make a folder in my projects folder, and we'll call it Thanos files, I guess. This is as good a name as any. Let's see. So first of all, that's just gonna be probably a single C file, and I guess we could compile with make. So let's do that. And Thanos. Let's just call it Thanos. Why not? So that's gonna call our C compiler with all the warnings, even extra warnings, and it's gonna be C89 because, you know, for extremely useful tools like this, you really want maximum compatibility. And we're gonna output this as Thanos, and we're gonna use main.c as our file name. What else could be useful? I think clang formats could be useful if I can remember the syntax. So that's in place. Let's add it. Formats, clang formats -i main.c. That should do it. And cleaning. I don't think I'm gonna need a clean function for this. So let's give it a go. Type make. It errors because I didn't put a main function, but you know, that's gonna be there soon enough. In fact, we could put that there right now. Yes, I will be doing it on all the system files. You know, not a pussy, so it's gonna be down to my luck. If I'm lucky, all the system files it targets should be, you know, bullshit, useless files. If I'm not lucky, well, why do I even live, you know? Okay, this stuff works. So let's start by, well, good way to start all my programs is hello world, so that'll work. And yep, that works. I really need to be careful running it like this because I might end up removing the source code. So let's also make formats here, so it's always formatted. Now there's one problem, is I don't know how actually how to use system calls, or I guess libc functions to get a list of files. So a good way to do it is always look at OpenBSD, how they implemented ls, for example, or rather not sure I want to look at something like BusyBox on stream because of licensing stuff. So let's see the OpenBSD core utils. think I have a GitHub mirror at least, so there we go. Ah, there, Alice. That should be useful. I remember there's something called dir-ent, which stands for directory entry. So let's search for that and see if it gives us anything useful. There we go. That'll work. Okay. This will be useful. So fd open dir is the function, it seems. So open dir? No, open dir, I think. Yes, there we go. Opens the directory stream and returns a pointer. And I think we're gonna just iterate that somehow in order to get all the files, but let's see. Open dir, read dir is also useful, it seems. So after we open it, we iterate with this probably. Let's see if they have an example here. No example, but you know, doesn't look too bad. So when we get the output, it has field dtype, for example, that tells us if this is a file or anything else. Yeah, so dtreg tells us if this is a regular file, which should be all we need. And then if we want to do it recursively, of course we can do that as well by detecting folders and then, you know, going into them. And it returns null when it reaches the end, so okay. I guess a good starting point will be to make like an ls replacement. So let's see, dir-ent.h. Let's include that. Also, I think Clang format has something to sort the includes. There we go. Let's change our makefile a little. Add this. What tool was I working on recently? I had something that I used. Is it? I don't recall it right now, but I remember it was really convenient way to format. Well, doesn't matter now. I say it doesn't matter, but it really bothers me that I can't find it right now. Ah, shit, what was it? There we go. Nice. It also sets like a column limit of 70, which is good if you want to post stuff in mailing lists, although that's not a common thing to do, I guess. Well, doesn't matter. Let's get back to our code. let's see, this should open the current directory, and we should be able to printf. Well, let's start with a pointer to see if it returns null or not. So yeah, let's try that. Okay, there, it prints. It's not null, so we can say it worked, I guess. Is that basically just a pointer we can pass to read there? Seems to be. Yep. Alright. So the thing I want to know is the first results. Well, let's also include assertions while we're here. And I'm just gonna assert that this is not null, so everything works. Incomplete type def there. Well, that shouldn't be the case. Ooh. Okay, I see. So we cannot access dname because this dir and the dir end are completely separate structs. Yeah, which is good. Let's see, what could we put here? Could not open the current directory. That's good, that handles that error. So let's put a while true, I suppose. Okay, need to include std bool because C doesn't have booleans. Right. And is that a pointer returned by this? Yep. And well, that'll work actually. So let's try to do that. Structs. Alright. Can we do a type def and get around that? Structs dirent and like this. Does that work? Yep. Sure does. And this is a list of our files. And it's segfaults because it goes off and tries to read everything, so is that really compiling as C89? Because why can I define variables here? Is it because it's a different scope? Can I do double test, for example? Right, it forbids mixed declarations in code, but still looks like it's doing C90 and not C89. Maybe this can be fixed by calling C89, which is supposed to be there on every POSIX compatible system. Well, GCC just doesn't give a shit, I guess. Oh well. Yep. Literally doesn't care. Is that really the case? I feel like it should work. Okay. Webcam's not frozen. chosen, you know, Linux webcam problems unsee. Ah, that's great. Cool. It says it's equivalent to C89, but I guess it's just, well, like, you know, extra filters on top of the code and nothing too concrete. It's not like a C89 compiler. It's like, oh, modern C compiler, just check for some C89 things. So I guess every C89 program will compile, along with some not really C89 programs. But anything that compiles with GCC's C89 mode might not compile with an actual C89 compiler. That's fine though. Also, this struct thing doesn't really bother me, so I'm not gonna bother with typedef. Right. So that's that, and if DE is null, then I'm gonna break, which should prevent that seg fault from happening, and it doesn't. But I still try to print that. That might be why. Let's try that. There we go. It goes all the way to hello world, and well, it's not really sorted by anything, but that shouldn't matter. One thing I noticed though, we are gonna need to filter out the dot and the dots, because well, if we're not recursing, well, if we're not recursing into subdirectories, we're gonna need to filter out all the non-regular files, and if we are recursing, we don't want it to go to the current directory again, and certainly we don't want it going up, because that's surely gonna break a lot of things. Right, so let's add that first. Let me add a few more flags. You know, make our output small, run fast, optimize all of that stuff. And let's add something to compare strings. So const char pointer. Let's see, let's call them S1 and S2. I honestly don't know why they don't include this by default, but you know, because it's very, very, very handy. Now, we know it's not null at this point, so what we can do is, if the so if it's dots or dots. In these cases, we just want to skip over this file. And there, the dots is still there. I don't like that. Ooh. Yeah, that comma is gonna mess it up for sure. Should actually be or, and now it only lists the files. That's great. So the two things we're gonna need to do is we really want to get a list of all the files. We don't want to, do it online, because we need to know how many files are there in total to delete half of them. We can't do it while we're still iterating. And another detail is we want to remove random files, and not all, like not the first half is what I'm saying. So, well, I hope I didn't mess up my audio right now. God damn it. This is so finicky to get right. It doesn't matter. Yeah, so we want to load all of these, ideally in a dynamic data structure, so that we don't have a stupid file limit or anything. And then once we iterate all the files, we shuffle them randomly, and we delete half of them, and that's that. Just thinking, what's the best thing to do? Well, do I want to recurse into subdirectories? Because that's really gonna... How would that even work? Let's see. Well, let's do a void recursive ls. So I think we could, oops, I hit my camera, and now that's, it's okay actually. That's fine, not a problem. Yeah. We might need to keep the path somewhere, because I don't think this structure really has the whole thing. Type of file, inode number. What does POSIX have to say about read there? Maybe I can't use everything here. So there's this. Right. So we know it needs to have the inode number, and so the dname thing, and doesn't mention limits on file name, but that doesn't matter. Okay, so type, we cannot depend on type. Ooh. Not sure I want to bother myself, but like, POSIX check if, okay, we're gonna need to do like stats call. Yeah, we're gonna do fstat, and it's gonna tell us, oh, is this a... No, maybe just try to open the file. Either way, that's really problematic. I would much rather have the type. You know what? This is already, using C89 or even using C for this sort of mini problem is already just for fun, so might as well go, full POSIX and not do anything non-standard. So let's see. Okay, I will do let's do that. And let's do open dir with this path. Do the same thing here. Really do the same thing. Right. I want to use the one above. There we go. Everything compiles. No. I made a directory called test there. Let's put hello text in it. Hi there. So it finds the directory, but it does not find the file in there because it doesn't go recursively. Is that a requirement that we need to do? You know what? Why not? Let's say it is. So I'm gonna do POSIX check if path is a file. There we go. So we call stat on it. Right. And that takes a path and a buffer to put the output into. Okay. Right. Shall obtain information. Okay, so that's where it puts the information. We can do this is file so that, and let's have this. Whoops. There we go. So these two functions are going to be real similar. So function shall return 0. That's fine. We're going to read the path. Yeah, we already have it. So let's just have that. So that has mode of file, I think is what we want. No? IFNT. Mode T. Right, there we go. And they provide macros to test these. Oh, cool. That's nice. So I want as if reg to see if it's regular. Let's do that. As if reg st. What was it? D mode. St mode. There we go. Cool. Mode underscore T. Let's make a helper because we're gonna need to duplicate this code anyway, so let's do some cleanup in advance. We want that. That. What did stats return? An int. Right, okay. Well, results, and then we could assert results is 0. And I could not stat file. S mode, it's st mode, and that is st. Right, so mode is path mode. Is the webcam frozen? No, everything looks good. Dropped frames 0. Very nice. Got an email. Invoice from JetBrains. Nice. My monthly sea lion build is here. I think it's if there, right? Isn't it? Is. And that's also IS. Ooh, that's wrong. Mode, and of course that needs to be mode also. Right, unknown type mode T. Well. Mode T. The POSIX might not expose that. Nope, that's not expose sys.h. I already have that, and it's not exposed, so cannot use that. It's probably an int. Well, really don't like this. Could I use a size T instead? Because it's just like a bit field, isn't it? Cool. Does that work? It does indeed. But I'll just set it to null, and that works. Cool. So that's good. What I'll do is so let's always have these two checks, right? But on top, let's also do okay, I really want let's see. This is gonna need some crap. So I don't want to deal with memory allocation, and certainly not like cleaning up the memory, but I might have to. And I suppose it shouldn't be too bad, right? So if it's not null and not one of these, we're here. Now here we want to essentially build a path string, which is the full path and not just the name. And then if it's there, curse as print. So let's do that. File path, I guess, and could set it to that's not a problem. So file path is string cats. So we're going to concatenate these. And does it allocate itself? Nope, it just depends at the end of the first one. And destination must have enough space for the results. Well, I guess what I'll do is file path is, let's malloc some memory. So string length of path. So that returns a size t, right? Path length, let's just do it right here. Right, let's do that. Let's do path len plus however long this one is, and string, does that include the null byte? Excluding the terminating null byte. Great, because then I can just add one. How am I gonna combine these paths now? I am gonna put a slash between them. So let's do 2. And let's put a comment here explaining why. So +2 comes from the path separator and terminating null bytes. Nice. Cool. Now we need to zero that, of course. So file path. Duplicate it for now. String length name +2. Keep those two in sync. Or I could calloc it, right? Yeah. Let's do that so we don't have to deal with zeroing out the memory. Cool. So can it really fail is what I want to know. Because it shouldn't be able to. Why would it fail? Cannot, right? Yeah, it returns a pointer, but nothing about errors. That's nice. So let me just do file path. Right, and that's the source, so that's going to be path, and you know, you really shouldn't need these calls for that, but you know, why not? So now we have the full file path. Instead of printing just the name, we should be able to do file path here and get that back. Well, I never actually execute that, do I? Recursive ls. Cool, that's really nice. Now, after I print, what I want to do is, I want to free the file path. Well, let's see. We don't free it, right? It looks fine. The program will certainly run, and on any modern system, with a reasonable amount of files in this directory, it won't run out of RAM, but you know, why, look, we leaked 32 kilobytes, and that's a tiny folder. If we do that, no leaks. Well, no, that's not right. There's still some leaks. Right. I know why. I know exactly why. That is because we never close there, right? Yeah, close there and the ends. Close there. And no leaks. But if I comment out this free call here, we leaked 40 bytes. That's kind of nothing actually, but yeah, let's be good citizens. And, you know, clean up after ourselves. Now, here's the fun part. We do if is there file path, then what we can do is call recursive ls with the file path, otherwise, well, let's do otherwise is file. Because it could be other things, like a lot of options. And let's do insert false here, because we really don't want it to be not dir or a file. So could not stat file. Why is that? File path here, see make file fails. Why does it fail? Really shouldn't fail. Right, stat. Else stats does links. All right. Stats relative path. It might need to be an absolute path. Well, now I want to see what is failing here. -1 on the make file. Okay, well, as -1, error no. I really want the error string though. C error string. String error. Let's print that. Too few arguments. Oh, balls. Do I really need to pass something? I need to pass error now. Right. Well, it's gonna complain, oh, I don't have error. No, please include. I'll do that. Error, no. I fucking hate error check. Bad address. Right. Bad address. Let's see why it could be bad address. Address of the bytes. Ooh. So it's not failing because of the path, but rather because of this. Maybe. Well, of course. Of course, it needs to be like that. There we go. And recursion works also. That's pretty good. Here's a good list of files. Goes recursively, only includes files. That's kind of good. That's great, actually. Let's see. External projects. Those files. Nice. Well, it gets kind of slow when it tries to access my external hard drive, but pretty fast overall. So that's nice. So now we can do it recursively. Instead of printing it, I would like to put it in a data structure, right? Let's see. Let's do a dynamic array, I guess. Huh. But something like a hash map. Not a hash map, but like a hash list be better? I don't really know. Let's do a dynamic array. So we have the file paths, and that can be we can't just append that stuff to a list like pointer to paths. We don't need to include anything else, and we can always realloc. Not ideal by any means, but should work. Yeah, let's do that. I mean, it has some memory, some performance issue, because you really shouldn't reallocate for every item in your list, but we could. We certainly could. Structs. So I want to store how many files we have, and just the pointers to them. So file list, guess could work, size t. Let's call it counts, and files. Alright, that's great. Now let's do... So we increment the count and then we realloc. Do we want to realloc or do we want to malloc and move ourselves? I want to realloc. So fl files is realloc. Realloc array is kinda cool, but it's a new thing, it looks like. Is realloc POSIX? It should be. But let's make sure. There, it works. And the parameters are pointer, so the current pointer. And, well, there. That should work. And fl files count -1. Let's duplicate that so that we don't need to free the directories but not free the files and this sort of thing. So let's just duplicate it and deal with that later. Right, void dump lists. Well, no, not gonna bother with that for now. Oh, didn't like that because this is not C++ land. Counts is gonna be FL counts. And string dupe is not a thing. It should be. We include string, right? String dupe really doesn't like. Ugh, are you serious? Bro. I fucking hate this. Oh well. Let's define that to be 500. And it works. How about that? But no, we're not really adding anything to the list, right? I'm just gonna use the global file list. So add file and get a pointer to file lists. So in either recursive ls, add file needs a path as well. Of course. Now it doesn't print anything, right? But if I do recursive ls found counts for files. Now, is that accurate? Well, 64 files, so it seems we now dynamically allocate an array and put all the files we find in there, so that's good. Now I want to shuffle that randomly. How would I do that? Well, could go fancy, but you know, could go with a classic. Just go with Fisher-Yates. Let's search Wikipedia for the Fisher-Yates shuffle. God, I hope my microphone's not cancer this time. I really hated the last recording. Modern algorithm. We want the modern algorithm. Okay, I want like this. So, right. Cool. So now this creates another issue. We want to be able to get random integers between a range. Is 64-bit enough? Well, obviously it is. No. I like reading from the view random to do these kinds of things, but could make our own RNG. Let's check the time. It's 2 AM where I am right now. We've been streaming for 1 hour. Yeah, you know what? Let's make our own random number generator. Well, actually okay, here's the thing. If I get random, like uniformly random 64-bit numbers and I need it to be between 0 and however many files we have, I'm gonna wait a long time doing retries. If I take the modulus though, that could work. It will be biased, but not by much, I think. And we're not doing RNG for a game, we're not doing statistics, we're certainly not doing cryptography. So, you know, that could work. Let's do that. So a good 64-bit mixer would be, I mean, anything could work, as we don't need it to be random in the slightest. So let's grab this one. Let's also grab something to rotate left, which would be, in our case, templates. Yeah, there we go. Rotates. What would I use? Only left 64 rotates. So let's grab that. go. Oh, it's actually a good idea to make things static as well. We haven't been doing that much. Well, let's leave that for later. So this RX Prime 64 thing is what's called a integer hash function. Which is like a random one-to-one mapping between every 64 number to every 64-bit number to every other 64-bit number, which is useful for things like random number generators, mixers, all sorts of things. So yeah. Now our RNG state could be a 64-bit number. Static RNG states. Right. So I'm gonna do init RNG, right? Yeah. So let's make it, you know, read from a buffer in order to get the seed. And I'll use that to feed it the current time and the current process ID, which should ensure random-ish results, certainly better than, you know, using the same seed every time, which will take the fun out of most things. So, RNG state equals RX Prime 64 RNG state, let's see, XOR bytes, and that's gonna be size I equals 0, I plus plus, what else, consts, yeah, we want to read bytes from that basically. And what's bytes gonna be here? Well, it's gonna be buffer I. Let's do that. Cool. Don't we include standard ints? Apparently we don't. There we go. So now we can absorb in there. Let's do a uint64t RNG next. Static, of course, for both of those. we want the upper 32 bits, so what's that, 4 bytes? 1, 2, 3, 4, so that's the whole thing. Oh, we want that. Great. And then let's flip the state again. And then this time put the low no, upper 64 bits again, but this time we shift it by 32, I guess. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. So that's our 64-bit number. Let's do that. And how is that in? Whoops. 1, 2, 3, 4. That's great. Lovely. And of course, we want to OR these. Cool. So now we can make random numbers. We can seed random numbers. So let's do static void. Well, and it's RNG. Oh, let's include time, PID, all of that. I really had this thing down. So there we go. Collect time and collect PID. I'll just use these to absorb, I guess. Absorb RNG. It's RNG absorb. Let's do that. RNG absorb. That. Get PID. Absorb the process ID. And also absorb our parent's process ID. That should be reasonably random. Need some includes, of course, which are time and where's get PID. Sys types is something I need for get PID. Think uni std sys types. Well, I think glibc is dumb, so I still need to have that. And of course include, what was it? UniSTD, yep, UniSTD.h. There we go. No returning function, returning 57. Right, of course. Cool. let's call here. Great. Now let's print like 10 random numbers and see that it is, whoops. Oh, just you? Oh, LU. Right, long unsigned. Call 75427. It's different every time, which is nice. That's what we want. That's what we want. So now our random number generator is done. Great. Dynamic file lists. Cool. So now we want to do the shuffle function. N-1 down to 1. Give me C code, bro. Really give me C code. Yes, modulo bias. What can I do? Really don't want to bother. Right, stream's still working. We should be nearing the end, surely. Ooh. Down to 1. So that means skip 0, right? Yeah. Let's do that. Size T index. Counts -1. Well, yeah. Greater than 0. So that's like an upside down for loop. Then we get a random integer. Right. J. I'll call it J. I'll call it I and J. sorry about that, to be consistent with everyone. So J is RNG next. Modular bias, no. That's fine. That's really fine. That's... if it's not len minus 1. What if it is len minus 1? Oh, well, if it is, we don't swap, is the thing. Right. Cool, so if j not equals count minus 1, which is also the initial count, really. I'll ignore that for now. Exchange J and I. I can do that. So there is a temp, which is files I files I is fl files J, and fl files J is temp. Great. That's that. Shuffle files is not done. Shuffle files, which are in file list. And then for I equals 0, I must file list count. Let's just iterate over the file list and print everything. So puts file list files I. And that should be a random order every time. Discards const qualifier. Ugh. TMP is bad. Let's fix that. Well, it's kinda randomized, but not much. So Thanos hello main make, Thanos hello main make, Thanos make hello main, main Thanos. Well, you know, not the best, but certainly should be fine. So that's great. Now what we need to do is unlink the files, let's say the top half of the files. Of course that's not the right man page. This is not the right one either. Is it too? Yeah, there we go. Well, POSIX, right? What am I doing? Call there, remove a path. Great. UniSTD, we already include that. This is a very simple API, so of course we're not actually going to delete anything unless the user passes like a really do it flag. LD, huh? Fine, I'll do it. Going to remove 2. Great. So int argc argv. There we go. We can really do it. It's gonna be, of course, false when we start. And it's gonna be if argc is 2 and the first argument then really do it is true. Otherwise, dry run pass really do it to do it for real. Great. Delete. Oh, the file has turned to dust. Of course we need to use the files. There we go, it's set but not used well. Cool, that's great. Where to do this? Where to do this indeed? Let's go to my cache, actually. That's the way to execute it, right? Let's go to cache. Lots of files here. Invalid next size. Are you serious? And did we overflow? GDB run backtrace. What is actually going on though? Invalid range. Invalid right size of 8. Why? what is actually happening. Let's disable all optimizations. And do it again. The impossible happened, huh? Right, malloc, add file, fails. Why? Is it really too many files? I'm gonna print the counts, because I think it's full of shit. File counts. Is this right? File counts. Boop. 4. And 24. Yay. That's not nice. So, FL counts. Ooh, right. Size of a pointer. Of course. Duh. Let's go back to our optimized code. And is there anything? Well, grinds. Well, didn't fail yet. Okay. We actually could not open one of them. But I think we should just ignore those ones. So, could not open the current directory, right? Could not open. There we go. Well, if you cannot open, just return, I suppose. Well, I guess it could log a little. Puts could not open. Well, printf, I guess, right? Could not open that. There we go. I think it has some like Go packages or something that really needs like roots to open. There we go. Yeah, some PKG ones. There. Did we leak fucking 3 gigs? Or 3 megabytes rather. Yeah. 3 megabytes. Still reachable. But why? Where are they? Oh, I know. So after we delete them, what we want to do is free all of them. So file lists counts, free file list files free all the file paths. That's great. Now it should report 0 bytes still in use. Well, 300 kilobytes still in use. What are we not freeing? Well, files itself. That's what we're not freeing. File lists dot files. That should be good. No. did I compile? Come on. No leaks are possible. That's what I like to see. Let's see, we're here. What's a good cache to clear? No, you know what? I'm gonna do everything. So, that's a bad idea to type my passwords with the webcam, so 1 second. Right, sudo should have cached my password, so let's do find here all the files. So we have 42,093 files, and Thanos also thinks there's 42,000. Well, it thinks there's 97 files. I wonder where the discrepancy comes from. Huh, that's really interesting. But I'm not gonna question it. Let's do it. So, really do it. A lot of files have turned to dust. And now we only have 21,000 files in our cache. Do it again and it should turn to like 10,500. Could not stat one of those files, huh? That's interesting. Well, 118. Alright, well, if you cannot stat, probably if res not equals 0, sorry, yeah, if it's not equal to 0, well, printf could not start file and return 0. Why can't we? Because it's a broken symlink. Well, I actually don't want to have symlinks, right? .174. Aha. Whoops. Well, we can get rid of this branch now. Cool. So, 21,000 files, 10,500 after that, please. 10,500. Do it again. Should go to 5,250. 5,260. Great. So we've Thanos'd those files out of existence. We've just went to those files and Thanos'd them out of existence. That's great. But you know, cached files. What are the stakes? Need something much better. Should I Thanos half of my music library out of existence? Well, I don't have the balls to do that. I'm sure I could find something though. Let's see. Just give me a sec, guys. Right, I'm back, and I found something that could be fun to delete. So I have this folder full of old voice recordings, probably of calls and meetings I was on while I was still studying. And, you know, this is not zero stakes, could be some useful stuff there. It's certainly not as valuable as my music collection or my archive, wink wink, of Unus Annus videos. So let's do our Thanos-snap here. Why don't we? So let's see. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 files, and our Thanos utility will tell us 16 files, gonna remove 8 of them. Should we really do it? Well, really do it. Bam! So now those 8 are gone. As you can see, we're down to 8 files. Let's hope there was nothing useful there. I've gone mad, I'm gonna do it again. 4 recordings is enough for anybody. So there we go. 4 of them are now gone, and I'm only left with 4 recordings. I did 2 Thanos snaps. Should be fine, I guess. This big one's still here. So if it's the long recording that has important stuff, should still be there. But otherwise, my files have been Thanos'd out of existence. I am going to copy the source code of that and put it on GitHub. Right? Let's sign in to GitHub. Let me just put this on secret mode real quick. I also noticed that ooh, that's interesting. Now my password manager doesn't remember which file I use, and my application launcher has lost its memory also. Should be caused by our cache Thanos snaps. Doesn't matter, all the data is still here if I need. There. Cool. Now I can turn this back on as we are logged into GitHub gist. Right, here's the code. Thanos-snap your half of your files out of existence. it is. Here's the file. I'll make sure to put that in the description. I'll post it to Twitch chat in case anyone watches the VOD. And that's it. We started with nothing but a hello world and ended up with a full program in C89 that does dynamic allocations and random shuffling and all sorts of interesting things. So thanks everyone for watching. I'll see if I'll do another live video this weekend, but doesn't matter. I'll see you guys in the next one. Have fun, have a nice weekend, and well, see you guys next time, I guess. Bye.